Dobar dan svima. Ja se nadam da se čujemo i vidimo dobro. Vjerujem da je 10 sati. Krećemo po rasporedu. S nama je Mihael iz AX3000 iz Villacha iz Austrije. Hvala puno, Mihael, što si došao. Nešto malo razumiješ, znam te. S nama je isto tako i Bojan. Bojan je glavna i odgovorna osoba u Sloveniji. Imamo nešto i ekipe iz Slovenije, tako da zamolit ću Bojana isto da se predstavi i da pozdravi. U svakom slučaju ovo je nekako zamišljen malo duži webinar, bit će do 2 sata će trajati, ali podijeljen u nekakve 3 skupine, jedna ne isključuje drugu, dakako. Prvo ćemo pokazati općenito što je AX3000 i kako radi. Obično kažemo, ako znaš crtati linije u CAD-u, znaš crtati, odnosno projektirati instalacije grijanja, hlađenja, ventilacije pomoću AX3000. Mihael će to dokazati. Nakon toga će biti možda malo više pažnje posvećeno onima možda koji već imaju sam AX3000 radi novosti u zadnjih nekoliko verzija u nekim novim featureima koji zaista jako lijepo ubrzavaju i olakšavaju rad, ali to ne znači da to nije za one koji prvi put vide AX, vidit će možda neke napredne funkcije i na kraju pitanja i odgovori. Ja ću se povući u pozadinu i pratit ću vaša pitanja u chatu, tako da slobodno pitajte ako vidim da nešto treba reagirati odmah, da Mihaela zamolimo da odmah odgovori na neko pitanje, ako ne, onda ću ih strukturirati tako da uštedimo vrijeme na kraju. Eto ga, toliko od mene, budite strpljivi, pitajte, gledajte, razmišljajte i svakako možete nam se javiti poslije webinara da napravimo i dodatne prezentacije, bilo online, bilo u vašem uredu. Hvala puno još jednom što ste došli. Bojane, izvoli.
Pozdravljeni tudi iz moje strani, iz Baldini studija Slovenije. Eko, danes imamo to priložnost poslušati gospoda Mihaela iz AX3000, da nam predstavi vse novosti in možnosti, ki jih imate v AX3000. Predavanje bo v 3 sklopih, tako da na koncu boste lahko dali tudi kakšno vprašanje, lahko napišete. Gospod Gianmarco bo v ozadju spremljal ta vprašanja in jih dal naprej. Tako da, evo, vabim vas na poslušanje in uživajte.
Michael, yes. You are on.
Thank you. So I will...
we see you just from the eyebrows up.
Okay, now my problem is it's implemented in my
okay.
screen, so it might be okay. Yes, so I will do a presentation for. So let's start a bit different. So hi, I'm Mike. I have to do it in English because I can't speak either Croatian language nor Slovenian language. I will show you and I will give you an overview about AX3000 implemented in BricsCAD. BricsCAD is a CAD solution working on DWG based, so it's comparable with AutoCAD, using the same functionalities more or less. You also can use the same shortcuts, so it's very familiar for every guy working in DWG files. It's also the same with layers and so on, but you will see it later on during my presentation. I will split my presentation into 2 or 3 parts. So at the beginning, I will share, let's call it a standard demonstration for all the new clients or prospects who haven't seen it yet. So a bit of heating, ventilation to see the workflow and the usage of the software. The second part will be a bit of new function for all the customers are knowing the software. So at the end, what we have improved or what we have changed. And the last part, few minutes, we will see how long the first 2 parts will take. I will do a Q&A session. So if there are any questions, we can do it. Let's say using the chat area, or might be by microphone. We will see. So I will start sharing my screen now. I hope you can see it. So it should be now one of the screens. and I will open or start with an empty drawing. So I hope it is visible now. Screen sharing.
Yeah, it works.
Okay, it's okay. So the implementation of the software could be on one hand using the ribbon interface. So there we'll find our functions. On the other hand, you will see at the left side, this we call it wizard. So there are different sheets. So one is a wizard, we call this assistant here, also to switch between the different trades. So there's one for room book. That means everything according to a room. So for load calculation, for heat load, for cooling load, maybe also to exchange data with other calculation softwares, or a building simulation. Then there's one for ventilation. There's a tool for heating. There's a tool for sanitation. So all the icons you need, you will find there. But we will see now how it works. So first of all,
Mike, just to mention, Mike, sorry, AX3000 is available for BricsCAD platform, AutoCAD platform, and Altan platform. So it works as a plugin, not a standalone application.
Yeah. So I forgot to explain this at the beginning. I'm using BricsCAD now. BricsCAD is, if you try to explain it, quite simple. An AutoCAD clone. It's more or less in some situations more powerful than AutoCAD itself. It works on the same structure like the layers, so you can use your layers. You might remember what is this pipe doing, so you can switch layers off and on. So the functionality is the same. The file format, the file format is also identical. So if it's flickering a bit on my screen, so that's okay. It's if I say save maybe, or save as, let's say save as at this case, I'm working on the same DWG format as AutoCAD is doing. So there's no problem if you use AutoCAD now to switch to BricsCAD, or if you are working in a company and you need new licenses to work with DWG to have a mixed environment. If you are working with the old AutoCAD versions, if you with BricsCAD, there's no problem doing in this. Sorry. The winter is coming, so maybe my throat is a bit damaged. Okay, first of all, I want to start with a process we call this easy line. So I will explain how to design a system, because that's the simplest way to explain this. This functionality or this process is can be used in all disciplines. So it's available in heating, it's available in drainage, in sanitary, as well as in ventilation, but it's quite simple to explain. And to do an easy-line system, you need 3 simple informations. You always have an endpoint of the system. We call this load point. This endpoint could be a ventilation grill, it could be a radiator, it could be a sanitary object. So you have a load point. At the beginning of the system, so at the other side of the system, you have, we call this starting point. So the starting point defines the system parameters, the medium, if it's air or if it's water or whatever. And between these 2 points, you need a path. So there you have the ducts or the pipes or all the elements, creating the system. So therefore, you can use a standard line. Line is, standard line, like in AutoCAD drawing a line. I will try to make a quite simple example. So I have started here with this plan view. The plan view at the moment is a 2-dimensional one. It could be also a 3-dimensional plan view. This will come a bit later. What could be the benefit of a 3D model, or also exchanging the data? So I will start on this 2D plan view with my load point. So the load point as a part, as the endpoint of the system, needs to know what is the representation. So I was selecting here some kind of grill. So all the objects, they might be parametric or they are original parts, are DWG files with blocks inside. So any user can create its own element. So that's the layout of my grill I'm using now. It's a parametric one, so there's a size table you can modify a bit. Same as for radiators, they are grown to the size the radiator should be because of the calculation. I define a flow rate. So at the moment, the flow rate is cubic meter an hour. That's my personal setting. But if you're not familiar with the unit, cubic meter of hour, or with any other unit like millimeter or meter, because you make a project, I don't know, for the UK or for US market or whatever, all the dimensions are flexible. So let's say I want to cancel the function. All the dimensions are flexible, so there's a small dialog here, and you can define all of them as you want. So if I prefer to work in ventilation instead of cubic meter an hour, maybe with liter a second, it's only one switch. I can do this. So now I restart the function, and then the software is asking for liter a second, and all the values are recalculated in real time. So former it was 150 cubic meter an hour, now it's 41.67 liter a second. I also can switch to some imperial code. So we have the possibility also to work the entire solution in imperial, and it's maybe gallons per minute or cubic feet per second, but that's not the reality in the European market as we are living in. Okay, let's start with the cubic meter or restart with the cubic meter an hour value. Then I have the connection cross section. I say I want to define it round. It could be a spiral seam pipe. It could be a flexible duct, whatever it is. Also here we'll find switch between imperial and metric ones. I want to have this cross section. This should be the lower. So the dialog defines what is the layout of the element, how it looks like, what is the value the software needs to calculate it. Here it's cubic meter an hour, and heating it's maybe watt or kilowatts. And I have an elevation because we do want to do everything 3D. So it's 3 meters. That's the bottom elevation of the covered ceiling. And now I need these grills on some different positions inside the drawing. Maybe I have decided this one. They are cleared with the architect. So I have decided to place them here. All elements we create are standard block references, so there are no special elements we are doing. So depending on this, the data exchange works. So if you open the same drawing with a plain AutoCAD or with a pure AutoCAD version, or import the same data into another CAD system like Allplan, maybe everything looks like completely the same, because it's not a specific proxy entity or user-defined block or whatever. This is on a block reference using attribute. So all the values are saved to the object as an attribute. So by changing an attribute like the flow rate at this property dialog in BricsCAD, it also changes inside the element for the calculation. So it might be 1, 2, 3 now. I do it only once. So if I double click the element, the dialog opens. I can see now this is also 1, 2, 3, but I can switch it back to 150 if I want, then it will be changed. Because they are blocks, you're using the standard CAD functions to modify. So might be I want to copy elements, I want to move elements, I want to stretch elements. Then I also do it by hand. So I move the dialogs, the grills in this area, because this huge area should have 6 of them. So that's one piece of the system. It is the end point. Let's call it a load point to make it simple. We also attach the useful informations to the, let's call it drawing cross. So if you move with the mouse over an element, I can see this is a ventilation load point. I can see the type, the flow rate, the connection. This can be managed a bit if you want. It's flexible. At the other side of the system, I need my starting point, no matter if I activate it in the wizard or if I switch the ribbon interface to the ventilation module. That's the same. So I will find the blue icon. Only to remember first, if I switch to another discipline, I will find an identical icon in the same color. So there's a red one, there's a green one, there's a magenta one, there's maybe a brown one. So the process is always the same. If you are able to use one discipline, you're also able to use the different or other disciplines. The main parameters are maybe different, another velocity, other friction, other medium, but the usage or the functionality is very close, nearly identical. So I need a starting point. And this starting point also should be elevated. I will explain the other values now during the presentation. So maybe the grill was on a 3 meter bottom, and this starting point should be on, let's say, 3 meter 65. So it should be a bit elevated. I want to have it somewhere here. So I have now the end point and the starting point. And what we are missing is the ducts and the pipes. So we need a path. And for this path, I use a standard line. So I can either use it here, or if you're familiar with a DWG-based system like AutoCAD, you can also press L and confirm. So the shortcuts are identical if you switch to to BricsCAD, there's no difference. In AutoCAD, it's also the same, so it's fine. I will start here with my first line. The line should go upwards up to this point, so this corridor area. Then I want to go in the next corridor to the right, and at the end I want to split it into two different duct parts. One should be at the upper area, and one should be at the lower area. So we have created our main duct path. What we are missing is the last connection for these two grills, and also for these two at the bottom. I want to connect them up and down, and this grill could be connected to the left side or also up. It depends on the situation. The same is maybe here connected up, or can connect it right. You can draw the lines manually, but it's not very user friendly, so there you will find the connection function. Same is for radiators. I want to connect these grills, all three of them upwards. I want to connect these grills maybe downwards. I want to connect this grill here to the right side. So they are connected now. And because we are working in 3 dimensions, so the grill, the bottom elevation was 3 meters, the line was a bit higher, and the function I was using was called connect from above. My line is higher than the grill. I got a horizontal line oriented to the ventilation grill, and then the line is going down. There also another function called connection lateral. Then the software is asking for an angle. Maybe these two I want to connect somewhere here. The angle was 45 degrees, so there's a vertical component going down 45 degrees. Plus, if I change it, let's say to 60 degree, 60, okay, for these two components, it looks like this one. So what we have designed now, you can call it a line system or a 3D schematic. So we have created a schematics of our system. The software is able to calculate something. So I can say I want to calculate the system. I decided I want to have a 3D representation. So I want to have all the elements in 3D. I want to see my ducts, my pipes. I want to get an output list. That's the second one. Then I select the system I want to calculate. If I select elements not be part of the system, they will be ignored automatically because the system only contains these elements. And also if they are unused elements like the line of the end, they are still connected to the system, but there's no load point at the end, they also will be ignored. So this takes a few seconds now, and then I get 2 different results for this ventilation system. One is a 3D model. So if I want to switch, it's called visual style. If I want to switch the visual style maybe to an X-ray mode, so they are lightly transparent, I can see through the ducts. I can see my ductwork here. This was the result of the calculation. And additionally, I got the pressure loss calculation. And like all other lists, this is exported to Excel. So in this case, I can see this is the main line. The main line is starting somewhere at the beginning. It's ending at one of these last grills. I was starting with 150 cubic meter of air. Let's make it a bit larger, might be. I was starting with 150 cubic meter of air, so it counts up to 1,500. So that's the maximum flow rate. The velocity was at least less than 3 meters a second. I got a cross section 600 by 250, whatever, and the pressure loss for the entire system is 35. So I know I can decide which fan I want to use. At the other hand, all beside lines are always calculated. In heating, the result will be a valve setting, a valve selection, a valve setting. But here I can see the adjustment value. So I have decided in this main line, or in this subline, in this beside line, I have to adjust 2.8 Pascal. Then I need 4 Pascal. Then I need 5 Pascal. Whatever I have to do. What's the main benefit or the main plus of this workflow? The main thing is you can very easy manage changes. So on one hand, let's switch to the plan view. Maybe I don't like this path, because let's say at this position I have a column, so I have to go around with the duct. or I don't want to go near horizontally, because at this position I need more pipe, so I can switch 45 degrees, then I have less pipe. Or I want to try a version with the entire round pipe cross section. At the moment I have a square duct at the beginning, sorry, a rectangular duct at the beginning, but it also could be a square duct. So also the connection is different. Maybe it's at the moment straight at the bottom, or if it's centric, depends on the setting. It's centric at the moment. So I have a few or many different variants I want to change, and this can be done quite simple. So the workflow means I switch back to the line system. So I delete the calculated system. Then I don't like this line system. One thing could be to manage it by using the stretch function maybe. So I want to use, let's say, a stretch. And then I say I want to stretch this point a bit, let's say, to the right. So this could be one way. The other way could be to say I delete the entire elements. They are still lines, so you can see they are still lines, but at the line are also all informations now available. So from the last calculation, I can see at this position I have a nominal pipe size of 250, flow rate was 450, or this line was 900 cubic meter, it was 2.8 meter. So, but they're still lines with all informations. So I want to have a new line maybe. You also can activate here the line function, or here, no matter which one you use. First point, second point, there was my column. Then I have my snap function with polar array, maybe a polar line, and I have a new path. The same works for vertical situations. So if I switch might be to an isometric view, I can delete an entire line, or I can shorten it maybe. So that's one way to go down, to go horizontally, whatever. Let's switch it back. Or we always try to make functions can help the user. There's a function called elbow jump, and by using snap function, so here I'm using at the moment nearest. Snap functions are similar to AutoCAD snap function. With the snap functions nearest, I select 2 points, and then I can define what is the height difference. So the next duct at this position or between these 2 points should be on -0.5, and the angle could, let's say, could be 45 degree. 45. So the software is attaching, let's say, this vertical loop going down, and this new line is 500 millimeter lower than this one. So I can recalculate the system and get a new result. Let's try it. I switch off the output list at the moment because there's no need. It will not be a huge difference in the pressure loss because only a few duct elements are changed. So it takes a few seconds, and then I get a new system. So I have my elbow jump. The line system was following this situation, so everything is fine. Or another variant could be, so I double click the starting point to change something, the starting point or the load point or the line or whatever. You always can use a double click. So I double clicked it. A second sheet. So at the top there's 5. That was so I switched to 5. So the maximum velocity was set to 3. So I switched it to 5. So at the moment this duct was using 2.78, so approximately very close to 3 meters a second. Now it should be 5 meters a second, and because the maximum flow rate now is 5 meters a second, the duct can be smaller. So let's try a next variant. Confirm, select. So that means this easy line process is quite simple to use. Or if I need now a variant with more round pipe, I always have the possibility of doing a bill of material. As I use maybe this parameter. So I want to use spiral seam pipe. Maximum pipe size should be, now it was 200. So I grow the maximum pipe size. That doesn't mean that I get only 710 millimeter pipes, but it means the software will use pipe until this cross section, this round pipe is used, and then it switches to rectangular. As well as here, there was the maximum duct height was set to 250 millimeter, depending on this. In the first version, the system was 600 millimeter width and 250 millimeter height. So I can switch it to 0 maybe. Then there's no limitation for the height. That means you always get a round shaped duct. Let's say calculate, confirm. Okay, then you get a different result. It's not a square duct, it's a round one, because we said you are allowed to use up to 710 millimeter. At this point, we are using 355. Depending on this, it was a round shaped duct. I don't know if it's very familiar in Slovenia or Italy, but what we have enhanced here is this middle area. We have grown the possibility of oval-shaped duct. So in older version, it was only available for round pipes and for rectangle materials. So this round pipes, there's a pipe database in the background. It's one database we use for all the different disciplines. So I have a ventilation discipline, and there is available these pipe cross sections. If I don't like one, I can copy, I can move, I can add. Same is for heating or for sanitary. That's also more important maybe to know the internal and the outside diameter, because the internal diameter is used for velocity, for Reynolds number, and so on, to calculate all these values, and the outside cross section maybe for leveling, because in a plastic pipe you want to level the outside diameter, and for a steel pipe you want to level the nominal diameter, and for copper mine you want to level the outside diameter and the wall thickness, so the difference between outside and inside. So that's part here. Let's use oval pipes for 1 second. So if I activate this function, the software will use oval shaped cross sections instead of rectangular. So you decide use either oval or rectangular. If it's deactivated, it switches from round directly to rectangular. If it's activated, it switches from round to oval. But in this case, I have to lower the maximum cross section for round pipes, because now I have no rectangular, no oval, everything is round. So I switch it down. Let's say calculate. So that's the main benefit of this easy line workflow, because you can, let's say, escape, restart the function, confirm. So because the software always creates a new version. So at the end it was a round one. I set maximum 250, and then it switches to an oval shaped duct, including the fittings and the D pieces to create a cross section. So it was this one, last one. I don't want to use oval. I want to use rectangular, but I want to use different manufacturing parameters. So there in the background is defined what is the maximum length of a duct, what is the sheet thickness, what is the type of profile, and so on. I also want to limit the value to 250 millimeter. Let's say lower the cross section backward, and here this area I want to switch. If a pipe is connected to a duct, I want to have 100 millimeter branches. So former there's a T-piece, also here there's a T-piece. Then this round pipe will be connected directly with a branch, but not the oval shape. It will be round, because this is the last setting. So that was about it was about the easy line process. It was a bit about ventilation. So now this setting is without profiles, but it's a rectangular duct, and everything is available at the element, so it can be leveled. So for leveling, let's switch back to a wireframe mode. For leveling, I prefer to use the line, because the line stays always, and then the duct is a result. You also can level the duct, but this is more for the construction. We will see in a few seconds. For leveling, there's something we call this associated leveling. That's a compare of attribute. So inside the DWG file, there's a block reference. So this could be, so I can use one block, and inside these blocks there are labels. So it could be, in this case, a track number in compare with the X list, to see which position on the X list is where in the model, maybe flow rate and velocity. So I will do it for 3 elements. I will label maybe this duct maybe here, or I will label this situation maybe here, or I want to label this line maybe here. So I can see this was 150 cubic meter, this was 1,350, and in summary I have 500. And if I want to recalculate the system to 5 meters a second or whatever, all the levels will be changed, because they are always connected to the line. So that means easy line. On the other hand, let's make it quite short. We have something we call this construction. So the construction is like child's playing with these plastic bricks, Lego, blue bricks, whatever the name is. So you put one piece after the other. So that means I have a construction tool. I start maybe here. I want to go along the wall. So that's the second point. The construction dialog opens. I might want to work in this workflow with different viewing windows. So I switch viewport, the BricsCAD user interface, into 2 different viewports. I want to switch it vertically, so I have 2 of them. And also new in BricsCAD V26 format, there was only one of these look from, they call it. It's not a view cube, they call it look from format. There was also one. Now they have implemented it into every drawing window, so I can switch maybe this drawing window to an isometric, so I can use shift middle mouse button to rotate it. So it's identical with AutoCAD. So I have a preview. The preview is always in all active drawing windows. So at the moment here, I'm using a manufacturing parameter. By switching to another, I will get connection profiles. The duct has a width, let's say 800. The duct has a height, let's say 400 millimeter. I have a bit of problem because of maybe the GoToMeeting software is interfering with my graphic cards. It's always flickering. So at the end, I will maybe a bit crazy, but it's okay. So I have a width and a height maybe. I can decide the bottom height should be 0, so it's moving up, or here it's I want to see it on the left side, on the right side on my 2 ducts. It could be a distance of 100 millimeter. Let's do less, let's say 100 and see it better, or it could be 500 millimeter in front. Later on, you can use any function, move, copy, rotate, whatever you want to do to move it to another position. And then you can continue at any existing ducts. It could be this one. It might be, let's say, I want to have only a few components as a representation for the air handling unit. So it should be 800 millimeter width and height. I want to have an elevation at the bottom of is asking for meter, so I add 0.1, so it's 10 centimeter. It's a bit elevated. So if I look from the front now, I can see it's 100 millimeter above my 2D plan view. Confirm, and then I can decide which element I want to have. I want to draw ducts, I want to draw elbows, I want to have a DP, so I want to have some components, and I only want to draw one single empty box now. So somewhere here in the device, in the device area, the handling unit, I want to have, let's say, I call it empty part, and I want to have it with a length of 2,500 millimeter. Only as a representation. I can deal with single elements to say I want to have a filter, a fan, a cooler, a heater, whatever, but this is for me enough now. Confirm. The next point should be somewhere here. The BricsCAD is crying because might be the GoToMeeting software plus the screen update is a bit too much now, but it's okay. I want to have flexible nipple. Let's say the size should be 700 by 700. No. And the length should be 120, and I want to have it connected directly, place. So that's the first thing. I said you can use copy, move, whatever. To make life a bit simpler, there's always a node inside, so I can say I want to copy CO from this side to the other one. Might be here, so I have 2 of them. If I don't like the position, I use M like move it a bit to the right, and now I can continue. So I want to restart, let's say, at this position. I want to go to the wall, let's say here, and now in the construction area, I want to rotate. So in the middle, not for rectangular ducts, there's no rotation needed, but for an elbow or for a T-piece might be, I can rotate the element. If it's a T-piece, I can say I rotate it up, down, up, down, left or right, or I can flip it and then I rotate it in this way. So I decide always where I want to go to. So the second point should be at the end where I want to have the fitting. This side is what the wall. Then I can decide what is the orientation. I might be want to go up, might be I want to change the size. So I want to flip it to 250 millimeter. I want to have an offset, let's say also from 100 millimeter, so it will be subtracted automatically. Or I can use this button to switch in front of the line, centered to the line, or might be behind the line. So if I select the other wall surface instead of the one in front, I can be behind the wall, might be, if I want. So now it's okay. Let's say place. If I'm unhappy with the layers, so I can use match properties as a standard BricsCAD function. So I want to match the layer of this duct with these two ducts, might be. Then it's changed, because here I was using a layer ventilation grill, and this is on a different layer. It's on the layer ventilation supply air, maybe. So this duct is now on the layer ventilation supply air, and then I can restart. I want to start maybe here. I want to go vertically up, so I need a snap point, no matter if I snap the duct directly or if I only use some kind of polar function. So I was deciding a height, and now the length is calculated, the elbow is calculated. If I look from the front, the elbow is at the same position, so I can use the rotation. So it's going now outside the building. If I flip it one time, second time, third time, it's going the correct direction if I want to do this. And let's switch it back to an isometrics. No, I have to select the corner of the elbow, or use shift middle mouse button to rotate it. Or what I can do now is I try to connect the elbow with the other duct. I want to connect, so construction, first element, second element, and then BricsCAD or AX3000 on top of BricsCAD, or AX3000 on top of your CAD system, also AutoCAD or iPlan, is trying to connect it. So I get a duct plus an elbow, and this elbow is still one changing the cross section, because this value was 700 and this was a bit less. So it's an asymmetric elbow also used by the software. So this was 600, the other one was 700. So the elbow is it's going from 600 to 700 millimeters. So that's one hand. At the other side, if you take a look, there's no difference if the elements are coming from EasyLine or from the construction. They always look the same. The difference could be that you're using different manufacturing parameters. So here I was also viewing the connection profiles there. It wasn't visible. So I might switch for the next calculation for this starting point, or for the system connected to the starting point, another manufacturing parameter that there are profiles designed. It's only a switch. And what I want to do is I want to make something a bit different. So I don't like this position. So I also can use the construction to restart at the duct. Maybe here I want to go upwards wherever to this position. So I want to be at the same position than this stair. So BricsCAD or AX3000 is calculating the length. The elbow is ending exactly at this position. Then I want to go up to the wall, but there I want to have a duct. So the duct is ending exactly at the position I was selecting. And now I want to connect these two ducts together. So I can use the construction. Either I start here or I start at the other side. Then this could be a transition if it's a small offset, or it could be an elbow jump. If it's a larger offset, the angle will be calculated, but I also can change it if I want. The last thing I want to explain about construction and EasyLine, and always remind, there is no difference if it's ventilation or heating or sanitary. Everything I've shown is completely identical in the heating part, in the sanitary part. We will see in the next step. There is one small thing I have to recognize. So if I switch now back to EasyLine and I say delete the calculated system, the software recognizes where construction is done and where EasyLine is done. So at this situation, I don't like to calculate it directly, because otherwise I have a problem with these two lines. This was the old path, so I get the old system. So I have to combine this together, and you can compare it. If you think about cars, that's quite simple to remember. You can call it, let's say, a hybrid system. That means a few of the ducts should be calculated by the software. A few of the ducts should be drawn by the user, because it's more complicated. The function is quite simple, so I have to shorten the line. Inside every duct, at the beginning, there's a node. So if the line is ending at the duct, or a pipe, and the other next line is restarting at the duct. You have now a combination. I will delete this duct first. I have a combination of some areas the software is allowed to calculate, a few areas the user was deciding something, and then in another area the software is allowed to calculate something. I split the line into two pieces. Why? Because here this cross section will be used till to the end of the line, and then here the software will be able to manage it if it should be larger or smaller because of the calculation values. And to do this, I will rise the velocity, let's say, to 5 meters a second for a second. Then I get a smaller duct, the transition. My duct stays as it is. This will used till the end of the line. Then it comes to transition to the smaller one, because in this area the software is able to calculate. And because I was changing something here in this area, I will move the level as well. This level is still connected to the line. So in the last calculation, the velocity was 2.778 meters a second. Now it should change to 5 meters a second, as well as in the other calculations. So last time, calculate the sanitary system, and then I can go forward to an heating area. So now you can see it's still 2.7 because it's coming from here, but the next duct is smaller. This is also 2.7 because the cross section is connected to the grill, and it was still 160 millimeter, but at this position the duct seems to be smaller than before, so it's 4.2 meter velocity inside because the flow rate hasn't changed now. So that's a bit about easy line and construction on the example of a ventilation system. So, and here, if I want to finish everything, I want to have a construction situation between these two elements or between these two ducts. So the software offers me in the connection area a transition. So everything is fine. And it looks like in this way, if I switch, let's say, to now use modeling maybe in this area, so it looks like this one. So that was the beginning of the first part. If you have questions, we can do this at the end. So I will let a few minutes left to have a Q&A session if there's something you want to ask. So let's switch to the next discipline. It could be heating in this specific situation. And specifically here, I want to start with a load calculation. So everybody has a building, needs a load calculation. It could be for heating, it could be for cooling, might be you want to make a simulation. So I have always some kind of base. It could be a 2D plan view, it could be polylines, it could be a 3D plan view, it could be an IFC model. On the lowest level of information, I need only a 2D drawing containing lines as a base. To make life a bit simple, I want to switch off now my layers. On one hand, I can use the layer dialog of BricsCAD, so I can select a few layers, I can make them invisible. On the other hand, what you can do is you can use this layer sheet. So it's parallel in this position to the wizard, it's the layer sheet. And in this layer sheet, we are recognizing our layers, and we grow automatically filters. So I can open the ventilation filter. I can see which layers I have made still invisible. I can make this also manually here, but it's always the same as at the other side. So no matter if you use our filters or the BricsCAD solution, and to switch off an entire discipline, this right mouse button is quite simple, because then there's no need to select something or say all filtered layers. That means they are inside the filter. I want to switch off, so the entire system is switched off, and I can continue quite simple with heating if I want to do it in the same drawing. Yes, I switch also the viewports to a single one, because now no second viewport is needed, and I want to switch to the plan view. Wizard. So first of all, while starting a calculation, you always need a location. This location has to be defined once for the project. You also have to do it at the top of this wizard or assistant or whatever. So I switch to Croatia at the moment. You also can switch to Slovenia if you want, but there's no huge difference. I want to switch to Croatia, and now I switch either at the wizard or maybe also here to the room book area, because I will do the the load calculation. Sorry. This calculation will be done in 3 steps. So the first step is to enter the main data, so the location and the outside temperature and so on. The second step will be to define my rooms. So we create something we call this room book, and this room book is used to process the calculations. So there are all the surfaces inside the areas, the connection to the wall types, and the last one is called room manager. So all the calculations are visible here. They are processed in this dialog. You use this function to export the lists. So I start with the location first. I want to use Zagreb. So I use the search function. I use the location. You can also handle this by the area. In German, it's Bundesland. I think in Croatia it's called Gespanschaft, but I don't know what's the Croatian word for Gespanschaft. So I've decided what is the location, but Sada was wrong. I want to have Zagreb, but Zagreb is not part of Sada, so I can search in this way. Let's say it okay. Then I have to decide what the north direction. So for the first try, I will define that north is at the top of the system. So this is the northern facade. This is the southern facade. I might want to define what is my thermal bridge addition factor, or what is my value I want to use for the density of the building. It could be very dense or less dense, so it switches automatically, and confirm okay. And if I want, let's do it the second time. Okay, I can use this north arrow function. So at the end of the dialog, let's say, I don't know why it's not remembering, but I think I have something. Why it's flickering. Okay, cancel. Now it's remembering. So if I want, I can place a north arrow somewhere inside the drawing. So this symbol, it's a block reference, can be modified by the user. If you want to have another layout, this north arrow shows always direction north, so you know it's the northern facade. This is the southern facade, but there's no need to have it inside the drawing. It's only a reminder. Now we can define room books. So it could be either a BIM model. This will be done at the next part of the system, because it's more or less a new function, or we have improved this to a very good level. Then you can use polylines if I want. So the polyline means that there's a rectangular polyline for a rectangular room, or might be on other positions, like here I have a polygonal polyline inside the room. So that's the fastest way to create something. If there's no polyline, then I have to press the first point, the second point, the third point, the fourth point, the fifth point, and the last point to define the polygon of the room per points. And I have to do this for any room. If you have only 3 rooms, they are rectangular. You say 1, 2, 3, 4, 5. For the next one, 1, 2, 3, 4, 5, it's quite fast. But if you have multiple rooms or a huger building, then it's maybe simpler to use this polygon recognition. And if they are not part of the drawing, or if you prefer to work with an external reference, then you can use the polyline or the rectangle function of BricsCAD or of AutoCAD. Or in Allplan, this is a bit different, because in Allplan you have a room, and we acquire, or we use the room part of the Allplan model. There's at the moment nothing. You will have the similar one with IFC, but at the moment it's a 2D plan view, so I will use this polygon. Now the software is asking define the room points, so I can try to select the first point, and if there is a polyline at this position, we have finished. Otherwise, I have to do this, the second point, the third point, fourth point, and to close then the room. So now there was not necessary to have a second one. The room gets a room number, let's say ground floor 01. And I can directly select the type of the room from a list. So maybe if it's a, I don't know what this is, bathroom, because of the temperature is connected to the list value, but I also can insert the type of the description manually. So for me now it's quite simple. All the rooms gets as a description room, so I don't separate into room, office, corridor, main area, whatever. I only call them all of them room. I give all of them 20 degree. All of them has a floor height of, let's say, 3.5 meter from this floor to the next floor, or the room height as an internal one is only 3 meter. Also some kind of air exchange rates or mechanical ventilations can be defined, but I don't want to go so detailed into the software. So I press OK. Inside my plan view, now I get a representation. So this room symbol, also this is a block and can be managed by the customer. And so I say this is the second room. So then room number will grow by 1. The first one was room number GF01. This is GF02. But the other informations like the room temperature or the room name stays the same. So I have the third room, the fourth room, fifth room, sixth room. So I go one time along all my polygons. Takes a few seconds, but less than a minute, so I think it's okay. If I press the wrong button, right mouse button, then it switches back to have the next room, 16, 17, 18, 19, 20, 21, 30. Right mouse button, next one, next one, next one, last one. So all my rooms got a symbol. To make it a bit clearer for you, I switch off another layer, part of the architect's plan view. It was this text layer, so it's better to have a visualization of these room symbols now. If I don't like the position, it's on a block reference, you can move them. It also could be a dynamic block. So at the moment I can see the room name plus at the bottom the heating, the value for the heating from heat load calculation. If I don't want to switch it, I can switch to only room symbol, or I can attach also for the cooling module that the cooling temperature and the cooling load is visible. At the moment only it's enough for me to have the heat load symbol. If you remember, the plan view was 2D. So now I can start the room manager. So the room manager is now a collection of all my room books. So I can see there's a room number 1, 2, 3, 4, 5. At the top, I have these highlighting functions activated, so I can see the first room, the second room, the third room, the fourth room, or if I highlight a group of rooms, you can do this with Shift or column, or if I select the entire group, all my rooms are visible. If I check the first room, I can see that there's at the moment a small, I don't want to call it a problem. It was my own decision to ignore this one. So all my surfaces at the moment are calculated to an external component. So the heat load of the room is very high. So this is like a shipping container hanging on a rope that all the walls are identically, whatever the construction is. But U value is 0.31, so that's the U value, and it's exposed to external air, so the factor is 1, depending on the load is very high. So what I do now is I use this function called determine adjacent rooms. So the software should find out if a wall is internally or externally. So this function will now check every room, every wall, and if there is another room at the other side of the wall. So in this area, there's no wall, so this must be external. This wall is an internal wall because there is a room, there's the same room, there's another room. It could happen that the walls are different thicknesses. So that's the main benefit of this function. I want to do it for all my rooms now at the moment. Then I have a few checkboxes. First one, please recognize internal walls. That means if there's a room at the other side of the wall, therefore a maximum offset is used, so it must be 0.5 meter. If it's more than 0.5 meter, it will be ignored. If it's less, it's an internal wall, and this will change the wall composition. So there in BricsCAD, in AutoCAD, in iPlan, you will also find the U-value calculation. You can create your own wall compositions if you want by making a new component. You can create your own catalog if you want of identical compositions you need all the time. You have material catalogs implemented, so there you will find many different materials, also manufacturer materials. So I will find a standard catalog of boards, and if it's a normative one. The yellow color I will change to green. Every wall type gets a representing color that you will see it later on. In the last layout, you have seen all the walls were represented in this ugly green. Now we're having different wall types. I want to see different colors, and I have decided I prefer to use this light green instead of yellow, because at the moment I'm using a gray background of my drawing window. But if I prefer to use a white one, yellow on white is not very clear visible, so I prefer to work with green here and ignore the yellow from before. So the internal wall I want to change. Then what I don't like is the floor and the ceiling, because also they were calculated as an external component. So I want to have the floor of the room should be ground connected, the ceiling should be internal connected. So I use these two functions here, ceiling and floor. I want to change it. So I select another component for all my ceilings. There I want to have this floor ceiling component. I flip only the picture a bit. So they have some kind of ceramic tiles, and then normal concrete and so on, bit of insulation to have the pipes inside with another U-value. But internally, this is an internal component. It's written on internal wall, but it's an internal component. The ceiling upwards, there's another floor. I want to change the floor ceiling. So at the moment, I have 4 floor types prepared. So this composition is more or less for me okay. So it's okay, but might be I want to change the bottom a bit. So I double it. So I say copy the component internally. Let's call it above a ground or ground base plate or whatever the name should be. Ignore if I write it wrong. I want to change, let's say, the bottom insulation. Instead of wood fiber, it should be something different. I want to have an insulation. Maybe it should be some kind of polystyrene or XPS or whatever it is. So I will change only the material no matter what it is. Okay, that's a different name. I want to have a different thickness, let's say 120 millimeter. And the temperature is in this case not an internal wall, it's not over external, whatever, it is some kind soil affected. It's a floor soil affected. So, okay, so the software now can change all the internal walls, the floors, the ceiling, and I don't like the external walls, so there I want to decide another one. Thickness of insulation is 120 and bricks is 250 millimeter. So it's let's say a better U value. Let's say I grow the 120 the insulation a bit. So now the U value is okay. This I switch off now. Then takes a few seconds, and now if I do a new layout without changing everything manually, I can I know that I have a soil affected floor. I have an internal floor ceiling. I have here an internal wall connected to room number 7. So I can see it here. Room number 7 was this room. Also, this wall is connected to room number 7. So these 2 walls are connected to 7. This wall is connected to room number 2. And different wall types are used because the thickness of these walls, or specifically, let's call it the offset between the rooms, is different. Because this is a 20 centimeter and this is a 15 centimeter wall. What we are missing for the entire model now are the openings. It's possible to create this till you create the rooms, the room books, or you can do it afterwards. In iPlan, by using the model, there's no need to do this step now, because the room knows what is the connected wall. The wall knows if there is an opening inside, and the opening has a size. So this room book is created entirely from iPlan elements. In the next step, I will show it in BricsCAD by using IFC. If you have a 2D plan view, I have two different window sizes. I have a small window and a large window. Let's call it a window large. Make it a small a, and then flip the characters. I have another window, window small. This has a width of 2.50 meters. This has half the size. I've read this from somewhere inside the plan view. And then I can either use an existing element to create this as a window, or maybe there's the same window if I want. Let's do it in this way. Or if this is a block reference, the software is checking if it's multiple times inside the drawing. If there is no block reference, like here, it is enough to draw a line, or use any other element, and there's also no need that there's a connection between your element you want to use as a, let's call it, placeholder. So this block reference down knows it is defined as a window. There was at the top this information like in ventilation. I can see it's a window, name window large. So this could be the line. There's no need to interfere or to cross the line. It's only a placeholder. And as a copy, CO, use a shortcut, because I say here I'm missing something, or it could be looks like this. And then I say I want to define an element. I want to have the large window. Either it is the block reference, or it is this line, or if it's this line. If I predefine the line and copy it, then it's still defined. The same can be done for doors. Let's say door. I want to have an internal door. I don't like the size. Meter. In the construction dialog, you might have seen a few values were in meter, a few values were in millimeter. So the software separates, let's say cancel, the software separates in the dimension area between big and large lengths. If you are boring with a setting like this, you can switch both to millimeters. And now if I open the door dialog, I have to insert 800 instead of 0.8, because now the value is still in millimeters. So let's say 2000. So I have a door 800 by 2000. This is a door, this is a door, this is a door, whatever a door is. So I select my placeholders. If they are multiple times available, they will be done for all of them. Let's switch back to the room manager. So now while opening the room manager and looking to the rooms, we are missing the doors. Now I want to attach them, the doors and also the windows, no matter which room I use. So it could be this one, right mouse button on any component, insert from cut, and then select if you want to add the openings or the windows and doors only for the selected room. This can be used to acquire one door or one window if you're missing only one. Or I can say do it for all of them. By selecting the entire plan view, the software knows there's a placeholder, there's a placeholder, there's a placeholder, and then tries to find out which is the nearest wall. Takes a second while reviewing the plan view. So I can say there was a small window, this was a large window. There are always large windows. Here I also have a small window. There's maybe a large window, so they're also implemented. In some situation, it could happen like here. If there are multiple placeholders very close to multiple walls, it could happen that they get one or two windows maybe too much. Maybe the same is done here, because this is a very huge block. This block is defined as a door, and it could be on the left side, the right side, so it could be done multiple. The solution here is quite simple. So I have to take care about room number, make it on this example 20 and 21. So I select the room first, second. So one is okay, the other one not. In this room, I can see there are two windows. One window is the correct one, the other one is the wrong one. So I select it, I delete it from the list. I save the change, and now it's done correct. So the graphics in this case is always used to do the representation. While closing the dialog, always the latest result will be written down back. So if I check the room number 14, the load calculation is now 666. Last time it was 581. So by closing the dialog and refreshing it, the values always are activated. So both rooms are identical window size, identical room size. So the load is correct. The other one is a bit smaller. The other one is a bit larger. So it's a smaller or a larger value. One last information about the representation. On one hand, the representation could be the geometry. So that means if I have a wall type, let's say an internal wall type, and we remember we have a color, but now I have multiple internal walls, I can use different color for different wall types. So might be the 100 millimeter wall should be orange, and the 200 millimeter wall should be dark green, whatever. So I have two different colors. The other ones are still green, so I don't want to change all of them. I will see this in my graphical elements to see on which position is which wall type. So also can see it now, 200 millimeter, 150 millimeter. There are a few walls are in concrete or 200 millimeter, and a few of them in gypsum boards or different sizes. So it could be one representation, and the other one could be here. It's called graphical analysis. So we always try to use the graphics as a representation. So graphical analysis. And now if I activate this, I can see my transmission losses. So in compare, in this situation, this is the wall type, and this is the transmission loss because it's activated. So I can see everything green has a lower transmission loss, everything orange has a higher transmission loss. If I check the U values, I can see the external walls have a better U value than the internal wall, but it was my decision that the external walls have 0.2 and the internal walls have 2 point whatever, is because of the construction or the composition of the wall. Or I can say what is the wall type I'm calculating the wall, and so if I make a mistake or if I do something wrong, I can find out quite simple why this is done. But I can also say I only want to see, let's say, external walls, then I switch off ground affected and internal walls, so my surface outside is correct. If I want to see only the internal walls, so these elements are calculated to internally, or these are calculated to ground connected maybe, and unheated means to an unheated room, to a garage, a floor, to the parking lot, whatever. Okay. To our left, and these are my main buttons I like. So on one hand, I can see what is the watt per square meter value. So everything is green. I have no red or yellow colored rooms. So I'm good with the result because it's always less than 40 square meter maybe. But I also can see the room temperatures now, and then now I recognize that this toilet area should have 24, so that could be a mistake. So I have to change this a bit, and it's room number 18 to 21. So I can select 18, 21. So I select them by using the shift button, all four of them, right mouse button, change floor properties, and then I want to change the room temperature. It should be 24. That's only one way to do it. You also can do it separately by double clicking the room. So now it's highlighted, and if I review all my rooms, I can see a different color because 24 is dark green and 20 is light green, and might be if I check watt per square meter, they switches to red because they have a higher level now. Okay, everything is fine. Calculation has updated. Because of representation, one step back for a second. I want to switch on all the ventilation layers. You have a similar function in a ventilation or in heating module for your results of the calculation. It's called graphical analysis. So in this case, I'm in ventilation, and if I want to switch on, let's say, the velocity, all my ducts are highlighted because of their velocity. So green means around 5. This cyan green, light green, whatever the green is, means it's 3 meters a second. Or if I if I want to see the pressure drop, it starts at the end with a very low pressure and then it grows up to orange. This for these elements I haven't processed the calculation. So orange means I'm something around, let's say, less than 80, but higher than 60 and lower than 100, because otherwise it should be yellow or orange. So this can be done. Or you might want to have, this is in sprinkler, a quite important function. You can highlight all the ducts according to the diameter. So if you have identical cross sections, the software will use the same color for this duct work, and then it's maybe for to mount it on the building site. It's important. So I can see the yellow ducts have somewhere 600 by 250. Also the same is done here, 600 by 250. This is a smaller duct. Also here it's a smaller duct. This is smaller, and so on. So all this I don't know, it is ugly blue, gray blue, whatever the color is. It's somewhere here. It's a nominal size 160, but you also can create a table if you have a pipe system where you're defining the colors. So let's switch it off. Also only some kind of site information. Let's switch back to the results. Filtered layers, fade it off. Okay. To process other calculations with the room, like cooling load calculations might be, you also can use the room manager by switching to the cooling module. So I have to define internal loads for the room. So might be, let's use these 4 rooms here, 8, 9, 10, 11. So I want to have 8 up to 11 shift. 8 to 11 persons, let's say 3 persons are inside, they are doing moderately work, so I have an heat gain inside. Sorry, yeah, then I have here some kind of no internal loads in this huge room, but here it's because of the internal loads and the external loads and so on. Window is in the direction north, while looking to another room here, direction south, let's say room number 12, the external loads are higher because the window is south oriented, and the other window in 8 was north oriented. So there are the solar gains. That's another result. So this could be processed in this way. I don't want to go too deep now. Or what you can do is you can process. We call this building simulation. So it's in this area. It's a building simulation module, Energy Plus. We use at this position. So what I do now is I will take one example. Let's take the room number 12. So I use the room. I create a zone. So if you have rooms with similar usage, with similar conditions inside, temperatures and so on, you can connect them into a zone. This zone gets an information about heating and cooling temperatures. So I use some kind of schedule. So it could be a single, let's call it, let's use the first one. It's a single office schedule. And inside this schedule, I define days. So on a standard working day, in case of heating, I have a 21-degree heating temperature from 5 a.m. in the morning till 6 p.m. And then I lower the temperature to 17 degrees. So I switch the heating off, it means, but I want to limit it to 70 degrees on a case of a working day. There are maybe for a cooling system a definition for the cooling type. So I define days. These days I combine to a week. So there's a working week from Monday to Friday, and then this day off is Saturday, Sunday, and this is combined to a year. But first and last week of the year is at the moment defined as a vacation. So there must be somewhere a week where I say the entire week is maybe off. So you can create this completely free as you want. Then into this zone, you also have to add internal loads. So I want to add, let's say, people. Let's say, call it persons. So that's the name of this usage. You can have multiple ones. Also, this internal load is combined to a schedule. So I can define, maybe I want to have the entire year the persons inside, or in case of office, it's a similar schedule according to the temperature. So they are coming at 7 a.m. in the morning and they go back at or go home at 6 p.m. In the evening maybe. So on and off for the same days. Similar situation. Value should be, I want to have 2 persons inside the room and they have an activity grade. They have normal activity, or they are sitting, or they are working heavy work. Then you have higher or less value. So that's the zone at this site. And for the project, I need a weather file. And these weather files can be, in some cases, downloaded from the website. In other cases, you can use Meteornorm to create them. I've prepared one. Let's say I will use another location. Now it's Split instead of Zagreb, because I want to see show the difference between a higher and a lower temperature area. So in winter it's not too cold, but in summer it's more or less very hot, specifically in July. And because of this information, now I can process a simulation. Takes a few seconds now. Okay, and now I can see the results. So I can process this for the entire building or for the zone, and then I can see that it's going up and down and up and down and up and down, because I have always the weekend. So the first week, second, so there was the week off, 70 degrees, and then it grows up to 21, and there's also up and down in case of heating or cooling. I can see I have to cool maybe the entire year because of the orientation and the location and so on, while changing the schedule. Let's say I want to have a schedule all day long. I want to have the heating all day long 21 degree, or I want to have cooling all day long 21 degree, and say calculate. I can do this for the process for the entire building. That means all the zones are used, or I can process it for a separate zone if I want to calculate only one, and these specific rooms, then I use the lower button. Then the calculation is done 2 times, and so the results will be more different. It will be more smooth, so it's still going up and down, but now also a calculation is done for the cooling load. So if the cooling system is switched on, it will be limited for this area from, let's say, day 70 in the year, maybe 3rd month, April, up to day 310, and then it becomes colder because there are no solar gains. But you also can switch up what will be the maximum room temperature you will become. And here in this area will be around somewhere, let's say 37, 38. You can see the temperature as a entire value for every room in a different kind of diagram. While changing the location, now I will change the location to Innsbruck maybe. I have another temperature grades. The maximum temperature is not as high. The lower temperature is maybe on a lower level. I can reprocess the simulations, and in this situation, it's fine to have a multi-core or a powerful processor, because all the cores are used at the same time. So the calculation is done quite faster than it's separated. So I have a different schedule. And if I look for the year now, my peak heat load will be 500 degree, and my cooling load will be 500 watts, and the peak heat load will be 0.231 watt. And I remember I was using now room number 12. So the orientation of the window was direction south. So while switching back to the result and changing the orientation, now the window will be in the northern direction instead of the southern direction, and this will have an effect to the result. So former it was, let's remember, 600 and 230. So I only have to process the calculation, because all the orientations are switched automatically. First one, second one, then the results are different. Okay. No, sorry, I don't want to process a new simulation. I want to see the results. So I have a less cooling load, but I have a larger heat load area. It will not grow much, because heat load is somewhere in the night when there are no solar gains. So it's more or less the same, but the cooling load is on a very low level now, because there are no direct sun radiation coming through the window. So that's about all our rooms. Last thing, and then I have finished this area of the situation. of the room, you can use an export tool. It's somewhere here. It's called GPXML export. Like architects are using IFC file to exchange their buildings, their walls, their windows, and the doors. You can use this GPXML. It's called Green Building XML file to export the room information. That's the standard interface to exchange data between different calculation softwares. Okay. So now to come to an end with the standard part of the software, we might can create a very small heating system. I won't explain many things, but I decide what should be the connection, what should be the valve of my pipe. Let's say I want to have some kind of radiator valve, and there are some settings inside. I want to have it connected bottom middle. I decide what is the type of radiator I want to use. It could be some kind of profile valve. I want to have temperatures. I want to have maybe length differences that the software is able to select something. I want to do it for all my rooms. And then I get my load points. In this case, they are radiators under the window. I get a list. Software was not able to do it automatically. They have to place my radiators manually, or I can delete a few of them and move them. And on the other hand, I got an Excel template filled with the results, so I can see what is the heat load of the room, what is the performance of the radiator, and what is the deflection between what I need and what I got. So I can see here it's about 6 watts, and I'm happy with this. The label are still attributes. So if I don't like the position, there's quite a simple function. So I want to move all the labels from the northern area, let's say to this position. I want to have it at the left side, let's say maybe at this position. It could be also oriented like this, or maybe oriented in this way. And the southern ones I want to have outside. So it was wrong. So let's retry it. I want to have it maybe oriented in this way. So this is the load point. Then remember, there was a starting point at the line. In heating, I need multiple lines. So I use maybe the multi-line function. I want to draw, make it quite simple. Draw maybe here. Then I want to connect the radiator. So I will find the connection function here. At the moment, I have activated the German user interface. While switching to the, I was not looking it, by switching to the English one, I will find the icon on the same function. I can use the icon here, or I can use the icon from the wizard. So I have it always at the position I need. I want to connect these two radiators, 1, 2. Users are still familiar with the software, will recognize format. There was a message box. You have to explode this multi-line. This is there's no need now. It is done automatically. I need a starting point at the beginning. And there also will find something for the next version. We have grown this area that you can save your own systems. In case of cooling, maybe you have a mixture of water and glycol or some frigand, and you can define this with a name, and then you can select from a list. At the moment, you have to insert it here. But for the next one, we have changed it. I have one starting point. I need a second starting point for the return, maybe here. And so I can calculate the system, and then I get a result. But in this case, I want to create also a list for a second and say, okay. So I get my system in 3D. I got a pressure loss calculation or a pipe net calculation or a hydraulic calculation into the X list as a result. So the pipes becomes a 3D element as in ventilation. Former it was a line, now it's a pipe. All the informations are saved to the element, so I can see a truck number, the cross section, the length, and the flow rate, and so on to label it. So everything is fine. And on the Excel sheet, this view here, I can see what is the pressure loss of the valve, what is the pressure loss of the flow of the return, what is the entire pressure loss once here or one time here, and I can see this was a track number 1. So I will find it here. So I can see how the software was calculating the entire pressure loss for the flow, the entire pressure loss for the return to regulate the systems. I have still something around half an hour left, so I will switch now to a few new things. For some persons, they will be new, but they are also interested for new prospects. So at the beginning, in the background of Mr. Baldini and his colleague, you were seeing there was something on the right corner. It was something about BIM was written down there. I have not the same background, so don't hurt me for this. I will show you a very short example of processing the rooms or the heat load calculation in combination with an IFC model. I will start this from scratch, so I will save the drawing. I will close the drawing. Oh, sorry, I've closed BricsCAD, but I don't want to close BricsCAD. I only want to close the drawing. So I restart BricsCAD, launch. Takes a few seconds. Then I will start with an empty drawing. It opens on the wrong screen. Open with an empty drawing. So it should be possible to see my screen now. Yes. Then I have here I don't want to load the user interface. Then I have here an IFC file. Let's take a look first into the IFC file. I will use BIM Vision maybe, but it could be Solibri or FZK viewer, or any other viewer as well. But in this, I'm familiar with it, and I can use drag and drop. So that's the model inside the IFC file here. It's a small building with a bit of trash outside, multiple floors. Maybe one is below the ground, a few is above the floor, and a few trees. So that's the model. And this model I want to import now into BricsCAD. So I use the standard import function. Ignore this message box. That means I have a license for the communicator, but no communicator installed. Communicator is an additional add-on to BricsCAD. That means you are able to import files from Creo, from Inventor, from CAD, so from CAD systems you mainly use for mechanical engineering. So you can use this, you can ignore this. I want to import now an IFC file, and I want to copy this path, maybe here. Let you see I import the same file as before. We have viewed. Takes a few seconds to import this IFC file into BricsCAD. So the result of this import will be a DWG file. So the process takes about 8 seconds. It was written down somewhere here. We were importing 8 seconds. If I take a look here at the moment, there is no DWG file insert, but if I say save as, I can save this into the same directory. So now I have here my F5. I have here my DWG file. I'm inside this. The result was this one. So these elements were imported into BricsCAD. All the walls and windows and so on in BricsCAD are from their origin as 3D solid, but these solids are classified. So that means this solid gets an information. I'm a BIM element. If only a single one is selected, it's simpler. I have one solid. I'm classified as a wall. I have a name. I am part of a building. I'm part of a story and so on. Then I have in BricsCAD something, a panel. It's called structure. It's the structure browser. You will see it here. The structure browser is also quite a nice function. You can create at the top different filters. So if I switch to a default filter, the filter belongs to entities. So it might be have a different first the layer, and then I can see what is the element on the layer. So there's a layer, there are block references on it. Or if I switch to a BIM filter maybe here, then I can see BIM elements like windows, like doors. So if I only want to see walls, I can say right mouse button, I want to isolate them. So everything is invisible excepting walls. So I show the entire model. Or if I say instead of BIM types, the BIM structure, then I can see the different floors. So if I take a look, this is my ground floor, and I isolate this. I only can see one floor, but I haven't switched off the external elements, or the external elements are also part of the building. And inside this model now, I have rooms. The rooms are connected to a wall. The wall might be a multiple layer wall, or have materials as a part of the IFC import. Let's switch everything on. Show. So if you try to process the same load calculation as you had done before, I need a location. So let's switch it back to Croatia. Then I define my location. I change maybe the orientation if I want to do this, or if I don't like the thermal bridge factor, I can change it maybe, or if I want to have different dances and so on, I define this. Sorry, I have to do it a second time. Okay. And now there's no need to use the polygons. Now I can decide to use the BIM rooms. It also works no matter, I don't know where this model was coming from. I think this was a Revit model, but it also could be an iPlan model, or an Archicad model, or maybe, I don't know which solution is also exporting IFC files. So I use the rooms. Then I can see directly a list of all available rooms. So it was, I was starting with an empty drawing. I was selecting it. I only do maybe the rooms of the ground floor. So I confirm the dialog, and I got an information. There are materials inside the model, and I'm missing physical values. So inside the IFC model, the materials like brick or concrete and so on can have also densities and so on. Say yes. So these are all the materials are inside. So they were this was originally a German model. So they are missing some surface. So the surfacing of the terrace, or maybe some kind of plastic to make it dense, or aluminum as a material for some kind of under construction. This was some kind of mineral wool, or maybe a wood and so on. I ignore the values because I only want to show the process. I don't want to process and enter a correct calculation. And so if I take a look into my model, I will see these rooms I acquired. They are according to this part. If I make it a bit more visible, I might want to make everything hidden, so I can use the layout or the representation of AX3000 to show it. If I check some kind of room, so this was a bathroom maybe, there are different wall types and so on in the material. What the software was ignoring might be the terrace outside, because there is some kind for lock rooms or for ignored rooms, and there was inserting some kind of text. So if as the name of the room is terrace or balcony and so on, they will be ignored. If I delete them, also these rooms will be part of the model, but they are not needed. So the living area or the residential area should not calculate the room to the terrace as an internal wall. But if there is a room, then it thinks it is done. Okay. If you select multiple areas, so I have my 3 floors, the upper floor, so the roof area, the upper one, and the ground floor, it takes a few seconds longer because I have to acquire more rooms. It also works if it's invisible, because I haven't deleted the rooms. I only have made them invisible to have the layout a bit better. Okay. Confirm room manager. And then I have my rooms of the first floor, of the second floor, and maybe of the roof, and also these balconies or terraces or whatever it is are part of the model now. So that's one thing I want to show a bit. It could be quite interesting, because the BIM process is more and more coming. Another thing I want to show is some for schematics. So we have started to create schematics to create them quite simple. So I save the drawing. Let's restart with a new drawing. Don't use centimeter. I prefer to work always in millimeter because then it's more simpler for me. So I don't want to explain the workflow in sanitary with EasyLine because there you need an object, could be a toilet, then you have a line as a path for the pipe, and then a connect and the starting point, and the software will create something. I will go a bit more into this scheme assistant. So might be if you want to have a scheme, you can use this wizard. So at the right side, I can define I want to have multiple risers. In this case, I've pressed it 2 times, so I get 2 risers. I get maybe 2 floors, another riser, another floor. So I can create here my basic structure. Here I have some kind of selection function. So by selecting green and blue works the same as in BricsCAD. So if I select it in this way, the riser plus the floor will be highlighted. By defining delete, the entire riser will be deleted. Same as if I select it here. If I create the window from the other side, I only select the floor, but I also can limit the selection to the object. So that means there's an object, there's a site, and there's an entire floor. So I want to delete this. Then in this area, I have to add components. So on the right side, you have a group. So these are internally, these are also DWG files plus blocks. So I can say I want to have sanitary objects. I either can use a drag and drop to say I have a toilet, I have an urinal, I have a washing basin, or at the bottom area, I can work with groups. So there's an entire bathroom group. So I move it to this point, or I move it to this point, and then might be I want to select these 2 elements to delete them if I have too much, and if I want to select delete, then it's identical. And maybe at the bottom I want to have a group called amateurs for the main. I want to have some kind of main water connection. I want to have some kind of hot water tank. I need this because there are some elements are using cold and hot water, and others they only have cold water. Okay. Schematics like this one can be saved to a template. So I want to use it maybe here. So it knows what was the last folder I was working inside. Maybe say it's XXX. Should not be some special name at the moment. So I can use now create, and while using the create button, the schematics is drawn into the drawing. So former it was an empty drawing. Now I have my schematics here, including the left side, the right side, my main water connection. Then there's the hot water boiler. In the background, this is a complete EasyLine system. That means you also can use on one hand functions like copy, move, or rotate. So if you copy an element, or you will find here a sheet called diagram, you have the same block. So if I say objects, I also can use a bar tube from here, double click, and then I use it maybe at this position somewhere. I want to rotate it in this orientation. Then I need lines to draw my pipes. Now the cold water line should be at the top, and the hot water line should be at the bottom, but not here. I have a different line course, and then I can use the standard functions to connect the elements. So I've switched to sanitary. I use the standard sanitary connection function. This element should be connected to cold water and to hot water, and this element should be connected to cold water and to hot water. Then it will be done. These lines will be ignored if I calculate the system, so it works. So that's one case. Reopen it. Also here it's this scheme generator. And then I want to open my template. I think this one it was, yes. You also can copy multiple floors. So if I select, but I'm not able to select the floor now. Now it works. I can copy them up if I want. Let's say 2 times. All of the floors at the moment have the pipes in the floor. This was a setting of my entire situation. So it's say connecting position is below. Every floor like this one, I want to change the upper one now, is the upper floor. it's using the connection defined in a scheme, but I can define it in the floor. So this is pipes in the floor. This is pipe in the floor. This is pipe now in the ceiling. It will not represent in the schematic area, but later on while drawing it was defined maybe here. Pipe position is above, or I can modify the piping. So I want to have a T piece maybe at this position. So it flips. Then this T end is maybe here. So you have maybe a T position, or it could be a Venturi valve to separate the flow into a loop maybe. Or if I want to add, let's say, armatures inside the floor, and then I let it go in this case. Armatures floor, it could be a water meter at this position. And if at the other side is only a cold water connection, let's say, no, I only want to delete this one. There's only a cold water connection. Take the same water meter. The software recognizes if I need one or two, depending on the connected elements. Last thing, I want to add an object, washing basin, but only washing PVC, potable water cold. So this is only a cold water washing basin. I will save my template. I will create the elements. I close it. I got a new result. So there are two water meters. There's one water meter. There are cold water connectors. There the pipes are at the top. So that was one thing we have made in this case. Then yeah, let's go back to our first drawing. I want to save it. Yes, let's call it sun scheme. This was our drawing from before. Floor heating. There we have also done something. We have a floor heating module. We have a few years inside the solution, but now we have made this completely new. That means the floor heating, the old floor heating module now was grown to a surface heating and cooling module. That means you can calculate the heating system for the floors as well as for the walls and for the ceilings, and then this calculated circuits for heating regarding to the position also can be used to know how many watts you can cool with the system. It's quite it's similar to guys or to persons are using them, but on the other hand it's a new one. So let's use 12 up to 15 as an example. So I want to have these rooms 12 up to 15. Like here, I can use now new drag and drop, so newer technologies are used. I can say this is distributor 1 maybe. Then this distributor 1 is calculated automatically. We have added the values as a sheet dialog, so this distributor knows what is the material in case of heating. So I want to have this Uponor Classics with a standard 20 centimeter in case of evidence zones. In border zones, I want to have a smaller offset. And save. Then have a material for the ceiling. There's another material catalog. We also added an editor. So let's say close. I have to close the dialog box first. So we have also added an editor here to manage your materials. Yes. Let's say I want to lower the temperature. Then the distribution properties areas. I haven't defined surfaces. I haven't defined which type of zone, but at the end I got the results. I have to restart the calculation now because I was lowering the temperature. It was processed automatically to create surfaces. So maybe as an example for the room number 13. So the user interface also differs between on the selection. So if I'm on the distributor, I have distributor functions. If I am on the room, I get room functions. And if I use now define area, it's different than this distributor area. So that I can see all areas defined in all the rooms regarding to this distributor or connected to the distributor. Now I can define it inside. I can say I want to acquire a surface. So I want to have a, if there's a polygon, I don't want to use it. Maybe I want to have one area, let's say here in the room. So it was defined. I can define a new surface. Maybe in, let's say, define area. No. Yeah. Let's say I don't want to do it by polygon now. I want to use it with a line. So the distance should be 1 meter. First point, second point. So the surface is calculated with 1 meter. So escape. So I've defined now two areas. One is 16 square meters. There's also a checkbox that it is highlighted if you want. There's a second one. One should be a main zone. The other one should be a border zone. And I have different offsets. And if I go back to the distributor and here, and I say calculate, I get different results because here I have now two areas. One is the main zone. The main area is switched into two things. And the third one is 1.3 square meter was the difference between my we can see it at the bottom because of the room surface and my two surfaces. So I have defined 16.8, 3.6. So there's an offset of 13. The entire room surface will be calculated. So the third one will be also used. By using this as a blind surface, then it will be subtracted because the room area is 21 and only 20.5 will be used because this will be ignored. This also will have a result then in this case, and confirm. Okay, the third one can be missed if I want. If there are no surfaces defined, if there are no surfaces defined, the entire room surface will be used. Go back, calculate, confirm, and and then I can use the cut function area to represent something inside the drawing. It could be either I want to represent my surfaces with a settings dialog with a color, or it could be a color gradient from, let's say, red to blue for an evidence zone, and for a border area it could be different maybe, or I use a single zone, or it should be some kind of hatching. Then I have to select the type of hatching, or if I don't want to have a very colorful layout, I also can say I want to create only the heat circuit labels for the entire distributor, so they are still there. The properties of the distributor itself also can be placed somewhere else, and this distributor now, but this was former the same, it's a bit rotated. This distributor itself knows the entire values of all connected rooms. It's like a load point, so you can connect this distributor to the first line and to the second line. And now if I recalculate, also these connection lines will be connected. So that was also something new. And if somebody was looking a bit more clear here, we have added the complete entire new area. It's called fan coil. In the actual English version, this fan coil contains 4 pipe systems. That means you have a load point with a heating with a value for heat load, for heat gain, heat power, heat performance, and cooling performance. It could be different. So we have founded a new load point. In older situations, you have to place 2 load points. So I have to define one with the heating value. Let's say I want to have 1000 watt, and the other one was for cooling. So I have another one with 1500 watts. And now there's one single load point. It's called, the function is called place fan coil. So everything is doubled. So I can decide, in case of heating, I want to have a performance of, let's say, 2 kilowatts. And in case of cooling, I want to have 1 kilowatt. So I have to attach both of them. In both values, you have a connection. So I want to have bottom left, or maybe horizontally left. So then it's at the top side, maybe somewhere here. The other one the same. but this is a different table, so they are moved more to the right side. I need an object for representation. Maybe I want to have this fan coil situation, this fan coil block with a size. You can manage it as your own, and it should be elevated, let's say, at 3 meters. This orientation at this side of the wall, or you can move it later on. You can copy it. And now I want to make it quite simple. Let's say I want to move it a bit into the room. Normally you might have it here, so I want to move it. I need 4 lines. I want to elevate all my lines to a set coordinate of, let's say, 3.50 meters, 3.5. So I'm using this elevation command. Then it's quite simple to draw the lines. I will make it quick and dirty. So I copy 1, 2, 3, 4. I'm ignoring the colors. So 2 of them are the pairs for the heating system, 2 are the pairs of the cooling system, and then I will find 2 connection functions. So one connection function is done to use this load point and connect it to flow and return. The other connection function is made to connect it to flow and return of the cooling system. And at the beginning, you need now 4 starting points. So we have doubled this area in this situation, heating flow, let's say 60 degree. Okay, confirm. We need also a return. So heating return, it's 40 degree plus material and so on. Then we need another pair of starting points. This is the cooling system, flow, and another temperature situation. It's maybe here. I ignore to change the layers now. So this is also cooling. This is the return. This is the other temperature. But I want to have another layer, cold water return. So this I change maybe. This I can double click to change. It's cold water flow. I don't like this large symbols, so I scale them down. Let's say I want to scale the factor to 10. Confirm. And if I want to do now, I also was able to copy it, maybe including all the lines here. Copy. So that's the main one of the main benefits you can do with AX3000, because I wasn't able, the elevation I wasn't changing correct, so I will do it later. Maybe by using stretch or something like, no matter what the height of the element is now. 3.5. I was inserting 3.5 millimeters instead of 3,500 millimeter, because the drawing unit is millimeter, and so it's not possible to do it. So no matter, then it's laying on the ground and the pipe is coming upwards. I'm not drawing a church. I'm doing only an example. What I can do now is, might be if I want to do is also here, the structure browser can help you, because if I select elements and I'm using a structure browser, let's call it default, for instance, and I select an element, it's here. You also can use isolate. This isolate command is also available as a separate function. So I want to select only my path and my systems. Let's do it in this way. So I only can see this system, so it's quite simple to work now. And if I want to move it up, I can use now stretch. But I see I have forgotten to isolate this line and this line as well. No matter, I will do it. I will modify these 2 lines manually. So I use the stretch command. Maybe I want to stretch the entire pipe system upwards. Then I make everything with everything from not height. I want to show everything, so I know I have to modify this line to go up to have the pipe maybe here, as well as I'm missing this line. It's maybe here, so I can move it, or I can say I ignore it. I add a new line. It's more simple for me. Okay, and then I can calculate the system. Let's do it in the plan view, and it's simpler to select. In this case, for this specific situation, I have to use the calculation function from heating, because both are, let's call it, sub-disciplines of heating. The result will be to get two different lists, one for the heating and one for the cooling system. I get 4 pipes, and all the pipes got their results. So if I check here, maybe the load point was 2000 heating and 1000 cooling capacity. So if I check the heating pipe, it's 2000, and if I check the cooling pipe, it should be one. Maybe the labeling is different. Let's check the line. So it's 1000 watts, and this was used for calculate the pipes. Only one view into the future. We have grown this, but it's only available at the moment in the development version, so it's still in German. But I have prepared a very small example only to show this. It will be available, let's say, at the first quarter of the next year. There we have also implemented now a 2-pipe fan coil version. That means I've made C demo. I'm sometimes an ugly guy and always close dialogues. I don't want to close, so I have to wait a second. My Windows Explorer is frozen because I was moving the Excel file over the network, and now it's searching inside the network. That's not good. Might be I try to open a second Explorer on the other screen. Then there's no need to move over the dialog, but I open it. Okay. At the end, HR, others. Let's say open. Copy the path. I only want to open a file. I don't want to. Now it works. Now, come on. Holy moly. So now it was opened. What was taking a few seconds. But I have opened the drawing in the old version. This I don't want to do, because in the new version I have a few multiple icons. There I have to say open. If you are talking 2 hours, your brain might be tired at the end. No, come on. Yeah. So what you see is this area was growing. So for the next version, this fan coil will be a new icon. Will get a new icon, but it's the same dialog. So we have the heating and the cooling area. Then we have created specific start points for this situation. So you have a start point where you insert flow and return, but you only place 2 of them, but these 2 have 2 different temperatures. So you have a flow with 70, but in case of heating, and 6 in case of cooling. You have a return of 55 in case of heating, 12 in case of cooling. This was the area I was talking about, the material. So the medium former, the viscosity, the density, and the area was always here, and you have to know the values. Now you can create your own combination and save them as your standard material. It's also needed for this case of situation. And the difference in this case is if I take a look maybe here to the starting point, I double click it. This was the old system where I have only heating and cooling and doubled. So it was like it was split into 2 systems, but this was the 4-pipe system. And there I have only 2 starting points. The starting point knows I am the flow 70 and 6, and the return knows maybe 55 and 8. And I have my fan coil load points. They know I have 1500 in case of heating. I have 1000 watt in case of cooling. And in this area, I have maybe made a new labeling area that I can see both values: the cooling value, the heating value, the cooling velocity, the heating velocity, because one of the systems, either heating or cooling, has to be used to create the pipe dimension. And for calculating, there's also a separate icon now. I switch off the output list because I don't want to do this. And while processing the cooling, in the dialog, I can see what is the value of heating plus pressure loss, what is the value of cooling, and then I decide which one has to be used to create the system. And normally at the end, when the system is drawn, I got two results. In one case, the pressure loss calculation with the cooling values, and the same system with the heating values. So it was a bit about new things and enhancements in the solution. The limit of the presentation was 12, so I have 1 minute left. If you have any questions, don't hesitate and ask. So then it's maybe 5 minute overtime or something like this. If you want to process more questions, don't hesitate, send an email. You can loop it through Marco's team or send it us directly.
Thank you, Michael, very much. I have collected a few questions, and I have a comment of my own. Even if our designers work in 2D, they are fully BIM compatible using AX3000, because you will generate 3D models with all the information. The only thing you need is capability to export to an IFC file. So AX3000 for many years has this floor generator, or how do you call it, manager.
Floor management.
So you actually don't need 3D from the architects. You can make a full BIM solution for any of the disciplines. You need just to export IFC file, which is possible in BricsCAD BIM. Unfortunately, I am not aware if the AutoCAD has this possibility. I don't think so.
The AutoCAD itself has no IFC interface, but if you are in a larger company, and mostly for BIM models, you are in a larger company, and also for companies using BricsCAD, you can deal with your licenses a bit. You need as a minimum a BricsCAD Pro license to create all the models. And if you have at least one BricsCAD BIM license, you can use this BricsCAD BIM license as an exporter. So it also can use this workaround in case of AutoCAD. So if you have one BricsCAD BIM, then you can export them as well. So in the meanwhile, during I was talking, I was trying to export the file. I've called it export end. Might be somewhere was looking or not, and the result is now in my model was this one. So regardless if the architect is working in 3D or 2D, all your elements are 3D. You are capable to export them into a BIM model. So if I have a duct, I have all the informations there, all the attributes there, and
there was a question about water and sewage, but you explained this is the same way. You draw the same way as any other module, but I can take care of it. So anybody who wants to see the sewage and sanitary in action, please give me an email to info@baldinistudio.hr, and we can do it separately. This is not an issue. Another thing, actually the first question that came when you were drawing a ventilation system, can you show what happens if you want to move a part of the duct? Does the system follow?
This depends on a function you are using. So filtered, show it. So it depends on the system, on the function you are using. If I select a separate duct, and this, no matter this duct is a block reference, and I use the move function of the CAD system, I move a separate element. That's it. By using another function, and this function is a part of AX3000, we have found it here. It's called move blunt parts. I can select a few ducts. Maybe I select this one. The selected duct stays as it is. Then the software tries to find the connection to the other ones, and then I can stretch it like this one. So if I stretch it now vertically up, this two elbows plus the ducts in the middle stays as it is, and the connection will follow. This works in multiple situations. So I use now copy maybe. Say CO. Maybe here. Let's add a few ducts, because I think that was a important questions. Let's say ductor. So you always select one or multiple elements. So if I use the same function and I select only one elbow, it's ugly, but it is. And I move the duct. The duct stays as it is, and the software always tries to connect the duct. In some situations, it will not work because then the angles of the duct are different. But if I use it in this way, the duct will be connected to the old system with two elbow jumps. And you also see that the length here in this area will be recalculated. So I get new straight ducts calculated, because then I say 1.5 meter was the standard. While moving it to the right, maybe like this one or here, then I only select it and then it's confirmed and then it's done. Okay. So there's a specific function for this. Additionally, there's a similar function to change the cross section. So I can select a few of the ducts, and then I can either say I want to have a nice new size, or I want to have plus 200 millimeter in width. And then by in this case it's meter, because in this drawing I'm using a different unit. So I say 0.2. So then it grows, and in case of this I also get the transitions.
Top. I have one comment which says excellent and very interesting showcase. And I have another question which I think it's very important. I will read it. Can you show us how to get 2D drawings from 3D with flow rates and dimensions of a duct?
Yes. What we have seen here, I see the plan view. So for me, this is a 2D drawing, no matter if it's 3D duct. I'm looking from the top, so I can see the two-dimensional information. I have moved out, in this case, the flow rate of the duct was the question, but I'm missing the dimension. To add the dimension, I can either use also an associated labeling. So I use a different template. Let's say here there's a template called dimension, and I want to use this one, then it's only the dimension in this case. So I can label the dimension out as well. It could be rectangular, it could be round. I can use the same dimension label. It could be one solution to see the dimension. Another solution could be to create your own labels, because this is only a block reference with attributes. So if I use this attribute and include this attribute in another template, like here, like this one, there's the width, the length, it's prepared for an imperial unit, so it's in inches, 14 inches per 10 inches, or it could be plus the cubic flow. So you can create completely your own system. This could be a solution. Or what you can do is there's a function, it's this one, it's called level at flange. So I decide I want to see the dimension, but I want to see the dimension only for ducts. In case of doing a production drawing, you might also want to see the position numbers, position number 1, 2, 3, 4, 5, that I have a combination between the drawing and the other one. So it could be this checked on. Then I decide which one. So I want to set this duct, maybe this duct, and this duct. So I will get on all these ducts the cross section, and if I want also the position number, if I check it on. Or what you can do in this situation, you can use this function also to automate it for round pipes. I want to see minimum, if a round pipe is longer than 1 meter, I want to see the cross section at the top of the duct in a distance of 10 millimeter. And by selecting multiple elements like this one, the software is checking if the pipe is longer than 1 meter. So this was 2.4 meter. This pipe was 1.0006. If I don't want to see it, in this case, I can restart the function. I grow my, sorry, I was missing a 0. So I want to have it in for 1.5 meter. And then I say, in this way. So I'm missing the cross section here, but I can see it here. And if I don't want to see, if I want to see a diameter symbol instead of the pipe, it depends only on the manufacturing parameters. So no matter how I open the dialog, in my material catalog, as a information to the material, there's the labeling, and at the moment it's set to a nominal pipe size. We're switching this to the diameter symbol. This one I will see for the next time. Diameter 160, diameter 180, or it could be another character, because I don't know Croatian what diameter means in Croatian. Maybe it's diameter or something. Then it's a D. Then I can and I can say I want to have a D. Then I get D 180 or D 160. I only know a few of you know me. Might be I know only know a few words in Croatian. I know veliko pivo, male pivo, hvala lepa, and something like this, but I don't know many more. So I also know energetska iskaznica, and the words I learn over the years, but I'm not able to speak Croatian. That's my fault.
You're not able yet. I have two more questions. What if we get a new plans with some new rooms? How to change it and how to repair installation calculations?
Then I recommend in DWG always work with attachments. So underlay your drawing as an external reference. You can do it by using the palette, or you can use it here like in AutoCAD. Attach it as an external reference. A reference can be changed. The polygon for the room can be, they should be in your drawing. So the polygon is in your drawing, and the reference is an underlay. And then while changing the reference, you also can use the polygon to check where the room is changed, and then you acquire these two rooms now. That's my workflow, but it's training. So
we have on our YouTube channel, Baldini Studio YouTube channel, we have separate videos how to make a story. It's a few years old, but the technology is the same. You can make floors and stories and actually attach not to have first floor, second floor, third floor, one beside another, but one on top of the other. So basically you create a building out of these stories that are one on the other. And this also uses the XREF technology. And basically you work in a new empty file, but you underlay different files.
It could look like this maybe. So there I can see there are multiple external references. A few of them maybe for the sections I've inserted here, first and the second section. I have multiple floors for this one. They are also using some kind of layer. Maybe here they are switched off at the moment, so I can use it in this way. I have multiple floors, and then if I want to separate the floors, so I switch on all the layers now. So there are also some kind of rooms inside coming. This is the room. The room books are visible now. I can use our layer management, for instance, to see there are. There are no floors loaded at the moment. Maybe the project management is switched off. There's a setting. It was switched off. Depending on this, I can't see it. So now I should be there. It's
basically you can have floors, BIM floors, even in AutoCAD, plain AutoCAD, using 2D files, no problem.
And then I can use the layer management here. Formerly we were using the discipline area. Now I'm using the floor area, and while double clicking, this is the third floor. This was the second floor. This was the ground floor, and the software is only switching layers on and off. It's quite a simple solution. We can train this, and that's okay.
I just want to comment on this. You can calculate every floor separately, and in your question I see connections. How do you connect it? You connect it separately in the separate system, because you can save all the results per floor. And when you connect the vertical lines, you can either connect them and calculate everything together, or you can have a separate system, vertical system, where you attach load points which read the results of each floor. So these are different ways to how to do it.
So Yeah, it's a very easy situation. So one way, if I do it, let's do it quick and dirty. I think we have the minutes. If somebody is hungry, then they have to wait. So I want to copy CO. Okay, let's delete this. So one solution to have different floors could be, so this was my example, ventilation, take an English, the English function. I want to delete the calculated system. So with a hybrid system as well. So let's say copy the second time. So one solution could be to say this is the starting point, and this starting point gets a name. If you want to have it one floor next to the other, it gets a name. Let's say this is my system ventilation 1, ground floor, shaft 1, whatever the name should be. You define what it is. Now, if you calculate the system, this name will be used to store or to save the information. System will be calculated. I get a result. I get a pressure calculation, everything. And then I can also access another drawing if I want. I do it in the same one, but it also works in another drawing. Let's say I want to do a vertical shaft. Maybe this is a floor I use multiple times. It also could be. So I want to have it multiple times. Let's say here. This is now my vertical. No, I want to use the green dot. Should go down. I need a starting point here. Do it quick and dirty. So I copy this one. This has no name, so I move it there as a starting point. And then at the end, I define a load point. And instead of inserting a flow rate or inserting a cross section, I say I want to use existing data from a load point. This could be one solution. And the other solution could be to design the system directly in 3D. So they have a second floor, I have a third floor. Sorry. Copy, CO. Afterwards, I have to ask Marco if he has the same problem, that if the monitor is always flickering when
No, it's perfect. Image is perfect on our side.
Yeah, on your side, but if you are sharing your data via GoToMeet, if it's flickering, it could be because I have connected 3 additional screens to my notebook.
You say your boss that you need a new notebook.
My notebook is quite fast, but I've learned if I have my notebook plus 2 curved monitors, one at the left and one at the right side, to have a cockpit, then also a GeForce 4700 goes down. Okay, so I have a system now like this one. It's a 3D system. If you want to do it like this, then it also works for calculation. But otherwise, I will ask Elias, my boss, next week to get a new notebook. And then I will say Gianmarco has recommended I need one. Okay, so now I have in a single floor, I have a flow rate of 7. So you can see now there's a D for diameter, and I have a flow rate of 750, and in the main line it's combined to 2250 because I have it 3 times one over the other. So both situations are working. That works in all disciplines. So always, if you have a load point, no matter if it's heating or ventilation or sanitary, you can decide that the performance is coming from another system, or you can handle it manually. Switch everything on. Any other question left, or was this enough for today?
There is one, I think it is, but there was a question, what about sloped roofs and so on? So I invited the colleague to go to our YouTube channel, Baldini Studio YouTube channel. Okay. We have very old video which explains how to make a roof sloped. There is no problem
in case of quite angry situation, I use now and make something quite ugly. I draw a box. I draw a second box. So I use solids now. bit inside, bit down, maybe in this way. Then I use subtract, sorry. So I want to subtract from this box this one. Then I use the command slice, and I want to cut this slice by 3 points. Maybe 1 point is here, 1 point is there, and the other point is maybe here. Yeah. I don't want to do it so down, so I want to also have the corner, but no matter. Every command can be activated either by an icon. So it could be this icon, means it's called room def. If I activate the command manually, we'll find something. It's called room def solid. In case of room def solid, I can select a solid element. Okay. And now if I check the room box, I get a room exactly with the geometry of this solid. So there's a ground floor.
It's easier than before doing it by hand. But there is also a possibility that you define a room maybe semi inside the soil.
Yes.
So
yes, that's also possible. That's
all the possibility there.
Yeah, there are multiple possibilities. You can use an IFC model, you can use a solid element to create a room, or you can use this function to create to change the room height. Sorry, it's on the right side, left side, somewhere here. There, change room heights. Then you can change it. Yeah.
So it seems that we exhausted all the questions. Thank you very much, Michael, for doing this for us. And I invite everybody to write us an email to info@baldinistudio.hr or baldinistudio.si for Slovenia. Bojan will take care of it. And if there is any questions, give us a call. We'll be glad to show one-on-one in a separate sessions and take care of all the questions they may occur. Thanks, Mike. Have a nice weekend.
I'm also happy to hear from anybody. If not, I say happy, nice weekend and happy Christmas. I know there are still a few days left, but if you take a look to the calendar, we have at least 2 weeks, and then there is maybe a few days, 2 or 3, and then we are all dancing around the tree and hoping that it's not burning down.
Don't worry. Hvala još jednom svima. Ako ste izdržali do kraja, heroji ste, ali za svaki slučaj poslat ćemo svima snimku ovog našeg webinara, tako da možete pogledati još jednom u miru. Svako dobro želim svima. Lijep pozdrav.
Ok.
Lijep pozdrav.
Bye. I will stop sharing.